Hi to all. Today we are going to discuss about the coherent sources, coherent light waves, path difference, phase difference between the light waves, and the relation between the path difference and phase difference. These topics we are going to discuss now. And first, what is the coherent source? Coherent source means source. These are the sources of the light, and the sources of light. The sources of light, the sources of light which emit which emit continuous light waves, continuous light waves light waves of same frequency and wavelength, and having zero or constant phase difference are called as coherent sources. This is the definition of coherent sources. What are the coherent sources? Coherent sources are the sources of light waves. These sources which emits the light, which emits the continuous light waves of same frequency and same wavelength, and they should have the zero or constant phase difference. Such sources of light waves are called as coherent sources. Now let us see here what is the condition for the coherent sources. If the sources emits the light with the same frequency, that means the frequency should constant and the wavelength of the light also constant. One more condition is that the phase difference between the two light waves. Phase difference between the two light waves. What is phase difference? The difference in the phase angles. Phase difference either it should be zero or it may be constant. These are the conditions for the coherent sources. If any two sources emits the lights with the if any two sources emits the light with the same frequency, same wavelength, and zero phase difference, then such sources are called as the coherent sources, right? And now, if not, okay, if if the frequency or phase difference changes, then they are called as the if frequency is not constant and phase difference is not constant, okay, then such sources, okay, then such sources are called as incoherent sources, okay, incoherent sources. If frequency and everything are constant means coherent, these are the coherent sources condition. Coherent sources should emit light with the same frequency. Coherent sources means emits the light with the same frequency, same wavelength, zero phase difference or constant phase difference. Then such sources are called as the coherent sources. If the frequency and phase difference are variable, then such sources which emits the light waves with the variable frequency and variable phase difference, then such are called as the incoherent sources. Now, next topic I am going to explain what is the path difference. What is the path difference? Okay, this is very important. Path difference means what? I will explain very simply. Path difference means it is the difference in distance traveled by the two light waves on reaching a point. That is a simple definition for the path difference. It is what? The difference in distance traveled by difference in distance traveled by two light waves, two light waves on reaching a point, on reaching a point is called as is called as path difference. This is the path difference. And what is the path difference? The difference in distance traveled by the two light waves on reaching a point is called as the path difference. I will explain with picture. You take the screenshot and note it. Okay. Let us take the, this is a source of the light. Okay, we will take one source of the light. This is the source of the light. And this is a cardboard with two pinholes. Okay, these are the holes. And now the, for example, this source is at equal distance from the two openings S1 and S2, and the source, from the source light started and incident at S1 and S2 also. After that, the light, this is considered as one screen we can take. Okay, and we will take one screen at here. This is a screen. This is a screen, and here light started at here, and one light ray is allowed to incident at here. It travel S1p distance to reach that point. Another light ray travel S2p distance to reach the point P. Look at here, the two light rays are moving, and one light ray started from S1. Actually, this is a cardboard with two openings. This is a cardboard, and it has the two holes, and through that two holes are the S1 and S2. That holes are called as the slits. S1 comma S2 are called as slits. Slits means they are openings. Okay, through that the light will passes. Now that S1 and S2 will act as the sources. You see here, from that S1 the light started and it reaches the point P. From S2 also light started and it reaches the point P. These are the openings S1 and S2. You see the figure, and through that the light will be passes, because they are the opening, through that light will passes, and finally they are reaching the point P from S1 and S2. And then what is the path difference in the distance traveled? Path difference is nothing but difference in the distance traveled by the two light waves. Then the first to reach the point P, the first light ray travel S1p distance. Second light ray travel S2p distance. Difference in distance, from figure we write like this. From figure we write S2p greater than S1p. That means, for example, if you take this as the first light ray, okay, and this is the second light ray. Second light ray travel more distance than the first light ray to reach the point P, because the second slit is at long distance from the point P from the figure. And now difference in distances I want to find out, right? Then the path difference is nothing but difference in distance. Path difference is nothing but difference in distance. I want to write the path difference formula. Okay, path difference is equal to difference in distance. What is the distance difference? First light ray travel, second light ray travel is 2p distance. First light ray travel is 1p distance. This difference in distance is called as the path difference. That is the path difference delta x we can write. That is equal to S2p minus S1p. This is nothing but difference in distance traveled by the two light waves on reaching point P. Okay, for example, we are taking that the two persons. Okay, the two persons are started, for example, one person started from market, okay, and the other person started from home. Okay, these are the two persons. The two persons are reaching the theater, let us consider. Okay, this is a theater, and now the first person travel, for example, x1 distance to reach the theater, and the second person travel x2 distance to reach the theater. Then the difference in distance traveled by the two persons, difference in distance traveled by the two persons, that is nothing but x2 minus x1. This person, the person who is starting from the home, he traveled a long distance to reach the theater because the home is at far away from the theater, but the market is little bit near the theater. That's why the person who is starting from his home, he should travel long distance to reach the theater, comparing with the person who is started from the market. And that means they are not traveling the same distance to reach the theater, right, from the figure. And then their difference in the distances, the difference in the distance traveled by the two persons on reaching the theater is also called as the path difference. This is the path difference. Path difference is nothing but difference in distance. In the path in from the figure, the path difference we write is the x2 minus x1. Similarly, the light from the two sources S1 and S2 are the slits, and they can act as the sources. From the original source is S, and this is a cardboard, and S1 S2 are the openings, means through that light we can passes. And now S1 S2 also act as source because through that light will be passes. And then from the S1 the light reaches the point P, and from S2 also light reaches the point P. The light which is starting from S2, it travel more distance to reach the point P, comparing with the light which is originating from S1. Okay, that means S2P greater than S1P from the figure. We write the path difference. Path difference is nothing but difference in distances. Distance traveled by the second light ray is to S2P, and second distance traveled by the first light ray is S1P. Difference in distance is S2P minus S1P. Right? Okay, have you understood now? This is about path difference. Now let us go for next continuation, that I am going to explain the phase difference. What is phase difference? Phase difference is nothing but a difference in phase angles. Okay, it was very simple. I will explain. Next topic is phase difference. What is a phase difference? Phase difference is nothing but difference in distance traveled by the difference in phase angles, not distance. Okay, difference in phase angles between two light waves on reaching point certain point. Okay, right, let us start here. And for that, first I will write the definition. Heading I will write, that is the phase difference. What is phase difference? Phase difference denoted with delta phi. Okay, or sometimes in some books phi also they will write. Okay, and phase difference can be denoted with either delta phi, or in some books you may write the phi also, there is no problem. And let us see here, what is the phase difference? Definition I will write, the difference in the difference in phase angles of two light waves, two light waves on reaching a point. Okay, or at a point, is called as phase difference. Okay, is called as the phase difference. Now let us see. I want the from the figure how to explain the phase difference. Let us see here. This is the cardboard. Okay, let's take it as the cardboard with two holes, and this is a screen, and it is the cardboard with two holes. S1 S2 are the two slits, and the light started from a source. It is a source is at equal distance from S1 and S2, and now here it is light travel like this in the form of wave. It can travel and it reaches the point P. And from here also the light started in the form of wave and it reaching the point P. And here this is the point P. Now actually the first light ray, this is the first light ray, one is first light ray. Okay, and this is the second light ray. On reaching the after reaching the point P, after reaching the point P, the first letter have the phase angle phi 1. Okay, at here the first letter have the phase angle phi 1. The second letter have the phase angle phi 2. Okay, phi 1 is the phase angle. Phi 1 is the phase angle at point P. What is phi 1? Phi 1 is the phase angle. Phase angle of first light wave at P, at point P. Point P. Okay, and phi 2 is the phase angle of second light wave. Phase angle of second light wave at point P. Now, what is the phase difference? Phase difference is nothing but a difference in angles. Difference in angles, phase angles. Then this we can write as delta phi, or the phi is equal to write as phi 2 minus phi 1. This is the phase difference. Okay, sometimes we write simply phi is equal to phi 2 minus phi 1 also. And the phase difference can be measured. Actually, you see this figure. What is this? Here, when it will first literally you see the second figure, you see. Okay, very carefully you have to listen. And you see the figure. First letter travel some distance to reach the point P. Second letter travel some distance to reach the point P. And here there is some path difference. And here when the letter is moving forward, its angle is increases. Phase angle will be increases. Okay. For every half cycle, the phase angle is increased by 180 degree. Okay. Then that's why after reaching the point P, the first light wave have some phase angle, that is phi 1 we are taking. Second light ray also have the phase angle, that is phi 2. Okay. The difference in the phase angles is the phase difference. I will explain clearly, some more clearly, and I am going to continue and take the screenshot and note it, and then I will continue after the rubbing. Okay, now what is the phase angle? And the phase difference is measured in phase difference. Phase difference. Phase difference measured in radians. Remember it. Phase difference measured in radians. That means, for example, 180 degree phase difference is equal to pi radians. You remember it. The 360 degree is equal to 2 pi radians. Pi radians. Now here, what is phase difference? I said that the difference in the phase angles. What is a phase angle? Little bit I will explain 1 second. And you see here one light ray is started at here and it is moving like this. It is moving like this. When it is moving like this, at that moment, this is a 0 angle. Here it is pi angle. Here it is 2 pi angle. Here it is 3 pi angle. This is the phase angle. Whatever that you are seeing, this at this point the phase angle is pi, at this point 2 pi, at this point 3 pi, 4 pi, 5 pi. Like this, when the light ray moving forward in the form of wave, its phase angle will be changes. Here at a particular point, the phase angle is phi 1. And if you go for another light ray, okay, this is another light ray, and it is also coming like this. Then after reaching at a certain point, the two light rays are meeting, and they are superposing it here. In this also, like phase angle will be increases it here. For example, it is 0, it is pi, 2 pi, 3 pi, 4 pi, like this. After coming to this, and it has some phase angle, that is pi 2. Like this, the two light waves, okay, first light wave have the phase angle phi 1, and second light ray have the phase angle phi 2 at a particular point. After reaching this point, then the difference in the phase angles, that is the phi 2 minus phi 1, it is called as the phase difference. Okay, right. And now let us see how the phase angle is increases when the light wave moves. You see here its direction of vibration will be changes. And for example, if the light ray, if you take like this, here it is vibrating in upward, here it is moving vibrating in downward. If it is zero angle, here it will become 180 degree. 180 will become pi. And if it comes again upward vibration, then 2 pi. Like this, the phase angle will be increases when it will goes forward. Difference in the phase angles of two light waves at a particular point is called as the phase difference. And then now we are going to discuss the relation between the phase difference and path difference. What is the relation between the phase difference and path difference? Relation between phase difference and path difference. What is the relation between the phase difference and path difference? You listen very carefully. It was very simple. That is, let us take the two light waves, and the relation is that the phase difference is equal to, just I will explain with the simple diagram also like this. For example, here this is a light ray. Okay, it is moving. Its light ray is nothing but a wave. It is moving like this. Okay, and for example, at here the angle we can take as the phi 0. We can take it as, and at here the angle we take as phi. Okay, you know that angle will be increases at here, and here it is angle become 2 pi, right? When it goes to right side, the phase angle will be increases. And now here the angle is pi, here the angle is 2 pi. Okay, and now this distance, for example, this is a point and this is the b point. What is the distance between these 2 points? That is lambda. Okay, and the lambda distance have the phase difference. How much phase difference it has? Phase difference is nothing but difference in angles. What is the difference in angles at here? Difference in angle at a and b. What is the difference in angles? Phase difference is nothing but phase difference at phi b minus phi a. I want to find out. That is nothing but 2 pi. What is the path difference? Path difference is the difference in the distance. From the figure, the difference in distance, this point is at zero distance, this point is at lambda distance. Write it as the path difference as lambda. Okay. And now here we write the lambda path difference. Okay, lambda path difference is equal to, if lambda path difference is there, then it is equal to phase difference. It is equivalent to the 2 pi phase difference. Lambda is the one wave. Lambda path difference is equal to 2 pi phase difference. Okay, right, this you should remember. And now for lambda path difference, 2 pi phase difference is there. For example, delta x is the path difference, phase difference is phi. Then the relation is we have to do the cross multiplication. Lambda into 5 is equal to 2 pi into delta x. Then from this delta x is equal to, or the phase difference, phi is equal to, we write as 2 pi by lambda into delta x. Now the relation is phi is the phase difference. Phase difference is equal to, we are getting it here. Phase difference is equal to, phase difference is equal to 2 pi by lambda into path difference. This is the relation. Okay. And now the phase difference we write as delta phi. That is equal to, or sometimes we write to just simply phi also. Then that is phi is equal to 2 pi by lambda into delta x. Okay. And this is the relation between the phase difference and path difference. And now let us take the some cases. If path difference delta x is equal to lambda, if delta x is equal to lambda, then what is the corresponding phase difference? What is the corresponding phase difference? Can you tell the phase difference from this you write from the equation, from this equation you substitute 2 pi by lambda into delta x is lambda, then we will get the phase difference as 2 pi. And now if delta x is equal to lambda by 2, if the path difference is lambda by 2, then what is the phase difference? You substitute in this 2 pi by lambda into delta x. Phase difference is equal to 2 pi by lambda into delta x. You see the cursor. In this delta x, we substitute lambda by 2. Lambda by 2, this 2 by lambda. Then we will get the phase difference as pi. Okay. Phase difference must be in the radians, not in degrees. Pi radian, 2 pi radian like this. Okay. And now this is the relation between the phase difference and path difference. You take the screenshot and note it. I will continue. Next topic is intensity of light wave. What is intensity? Intensity is nothing but the light energy radiated from a source. Okay, the light energy per unit time and per unit area is called as intensity of light wave. Intensity of light wave. The intensity of light wave, how to calculate the intensity? Intensity is nothing but energy, energy by time into area we have to write. Energy per energy per unit time per unit area. Energy per unit time per unit area. That means light energy is traveling through a window. Let us consider light is entering into a room through a window. Then how much light energy is entering per unit time per unit area through window area we can take. Then that is the intensity of light which is entering in through our room, through the window into our room. For example, we want to calculate how much intensity of light entering into our home. Then for that, we have to our light may be entering through our windows and doors or anything. Then how much light ray entering intensity of light entering through the window. Then we can take light energy by time into window area we have to take. Like this, we have to calculate the intensity. Energy by time is nothing but power. We write here power by area also. And the intensity unit is what? SI unit of intensity. The SI unit of intensity is power by area. That is nothing but watt per meter square. Watt per meter square. This is the intensity of light wave. And some more factors I will give. That is a light wave. This is a light wave. Let us consider it is a light wave. This is a light wave. The light is traveling in the forward direction like this. This is a light wave. It is moving forward, right? Like this it is going. And now here I want to know one thing on what factors the intensity of light wave depends. Intensity of light wave depends upon the square of amplitude. For example, what is amplitude? The maximum displacement of the wave. For example, this is the maximum displacement, and this is called as amplitude. This distance. Okay, this distance is called as amplitude. Amplitude is the blue line length. This length is the amplitude. This is the maximum displacement. Okay, and then intensity of the light is directly proportional to the amplitude. Intensity of the light is directly proportional to the amplitude. We take it as amplitude as small a. In the book it will be written as a small a, then we can write it as a small a, and then we will write here this is the small a, the small a. And here, from the figure, the small a is called as amplitude of light wave. What is that? Amplitude of light wave. Light will travel in the form of wave. We know that a is the amplitude of light wave. Then I will write some information that intensity of light wave depends upon some factors. Intensity of light wave is directly proportional to the square of amplitude, is directly proportional to the square of amplitude. That means intensity proportional to the square of amplitude. If you write in the ratio form, we write like this. Intensity I1 by I2 is equal to A1 by A2 whole square, we have to write. You should remember this formula. Intensity depends upon the amplitude. If light wave amplitude is more, okay, if amplitude is more, if A is more, then intensity of light is also more, right? And this is about intensity of light wave. And one more factor, the intensity of light wave is also depends upon the slit width. You know already what is slit, and you take the screenshot and note it. I'm going to erase, and then after that I will continue. Light wave, that is intensity of light wave is directly proportional to the slit width, or the width of the slit. That means width means what? For example, this is a cardboard, it's an opening, and now this width, right? And this is the slit width. Slit is the opening through that the light will be travel. Through that light will be travel. Like this, the light will travel. And the slit is nothing but opening. This is the slit. Slit is the opening. Slit is nothing but a opening. What is the slit? Slit is the opening through that light will passes. And now we are telling that the intensity of light wave is directly proportional to the width of the slit. Then when we write in the ratio form, we will get as I1 by I2 is equal to W1 by W2. If the slit width is more, then the more intensity will enters. And we can write even conclusion, and one formula we write, that is I1 by I2 is equal to, we write as A1 by A2 whole square in, that is equal to W1 by W2, we write. Okay, this is the formula which gives the relation between the intensities and width of the slits, right? The next continuation I am going to explain, that is the principle of superposition. What is the principle of superposition? Next topic is what? Principle of superposition. Principle of superposition. What is the principle of superposition? That you learned in the 11th class only. Then the principle of superposition is nothing but two or more light waves are traveling in the same medium and superposed with each other. Then the resultant wave displacement is equal to the algebraic sum of displacements of individual waves. Okay, and this is the principle of superposition. Okay, I will write the statement of that one. When two or more light waves, when two or more light waves traveling traveling through a medium, traveling through a medium, and superpose with each other, and superimpose with each other. Superimpose with each other. Then a new wave is formed. Then a new wave is formed. When two waves or more waves are superposed with each other, then what happens? New wave forms. In which resultant displacement, in which resultant displacement is equal to the vector sum or the algebraic sum of displacements of individual waves. Displacements of individual waves. This is the statement of the principle of superposition. I will write this in the equation form. Okay, you see very carefully. I will erase only left side. Okay, now I'm going to continue. That is what we are telling it here. According to that, when two or more light waves are superposed with each other, then the resultant wave displacement is equal to vector sum of displacements of individual waves. This is the equation that we are getting it here. And what is y at here? What is y? Y is the resultant wave displacement. Resultant wave displacement. Y1, Y2, Y3 are what? And so on Yn are the displacements of individual waves. Displacements of individual waves. Let us start it here now. These superpositions are two types are there. Okay, principle of superposition means what? For example, it was very simple. This is the first light wave. This is the second light wave. This is the third light wave. Like this, many light waves are superposed with each other. This one have the displacement y1, first one. Second one have the displacement y2. Third one have the displacement y3, like this. Then these three waves combine with each other. These three waves are combined with each other. Then one new wave will be produces. That new wave displacement is the resultant wave displacement. The new wave is called as the resultant wave. New wave is called as the resultant wave. That resultant wave displacement is equal to the sum of displacements of individual waves. Here you see the figure. There are three waves. Okay, there are three waves. You see 1, 2, 3. These three waves are superposed with each other. Then new wave is produced right here. Then the new wave displacement, okay, is equal to vector sum of displacements of individual waves. That is y is equal to we write y1 plus y2 plus y3. We cannot write always plus. That is a vector sum. If they are in opposite direction, we have to write minus also, right? And then that is a Principle of superposition. These superpositions are two types are there. One is a constructive superposition and other one is a destructive superposition. Okay. Now let us see what is constructive superposition and what is the destructive superposition. In the constructive superposition, how the light waves will be superposed with each other. That I am going to explain. These are two types. Okay. These are two types. First one is the constructive superposition. Okay. First one is what? Constructive superposition. Now, which is called as the constructive superposition. And in that, what happens? Constructive superposition means what? In that superposition, what it will happens? In the constructive superposition, the two light waves, okay, the crest of one light wave will fall on the crest of another. This is the first light wave, okay, and next, this is the second light wave. They are superposing like this. If they will superpose like this, then the resultant wave displacement, then we will get a resultant wave. That resultant wave is, we will get a resultant wave with more displacement. That we will get the resultant wave like this. And now this resultant wave displacement in this case, we write as y is equal to y1 plus y2, or the resultant amplitude we write as, resultant amplitude we have to write as a1 plus a2. A1, A2 are the amplitudes of individual waves. Okay, and here this we write as capital A, and this we write as a1, and this we write as a2. Then resultant amplitude is equal to we write as a1 plus a2, or the resultant displacement is equal to y1 plus y2 we write. Okay, because the crest of one wave falls on the crest of another wave, and during this you will get the bright band, more bright, because the amplitude is increased it here. We are adding it here. Amplitude is increasing means intensity is also increases, then the brightness increases. Okay, and the bright band forms due to this. I'm going to erase on the right side. Second type of superposition is the destructive superposition. Okay. Destructive superposition. Which is said to be destructive superposition? Destructive superposition. Destructive superposition means in that the crest of one light wave falls on the top of another light wave. It will be like this there. And for example, this is the first light wave like this. And this is the second light wave. Okay. If the first light wave have the amplitude A1, the second light wave have the amplitude A2. This is the first light wave and this is the second light wave. The two are superposing with each other. Then there is a new wave will be produces. For example, this new wave has the amplitude like this. There's a new wave amplitude is capital A. We have to subtract it here, either A1 minus A2 or A2 minus A1. That means here the resultant amplitude is less. And the resultant wave displacement here we write is y is equal to y1 minus y2. We have to write because they are in opposite direction. And the resultant amplitude we have to write is A1 minus A2. In this we will get amplitude as a minimum. Okay, because we are subtracting it here. In the previous case, amplitude is maximum and intensity is maximum. Here intensity is also maximum, right? Intensity maximum, but here intensity is minimum. Okay, why? Because intensity proportional to the square of amplitude. Here, this is the destructive superposition. In this, darkness will forms. Okay, and in this, what happens if amplitudes are equal? If a1 is equal to a2, then what happens? The resultant amplitude resultant amplitude become two light waves combine and forms a, there is a two light waves here. Okay, you see the figure with the destructive interference. One is the red light wave and other one is the yellow color. These two light waves are superposing. Here the crest of one light wave, this red color one is said to be crest. Okay, and this is the trough. This is the trough. The crest of one wave falls on the trough of another wave, right? Here in the previous case, the crest falls on the crest only. In the previous case, the crest of one wave falls on the crest of another wave. But in this case, crest falls on the trough. This is the destructive superposition. In the destructive superposition, resultant displacement is minus. We have to subtract them. If A1 is equal to A2, then what you are getting here? Resultant amplitude is 0 we are getting. Resultant amplitude is equal to A1 minus A2. But A1, A2 are equal means A will get as 0. Then we will get the dark band. Okay. Then in the destructive superposition, we will get the dark band. In the constructive superposition, we will get the bright band, because intensity is increasing, amplitude is increasing it here. Here intensity is decreasing and amplitude is decreasing, right? This is about the superposition. You take the screenshot and note it. Okay, let us continue. And now I am going to start the important topic at here. Now this is very important. Listen very carefully, and we started the important topic. From this, there is a chance to get the 3 marks question or the 5 marks question. And now that is first, what is the interference of light? Interference is nothing but superposition only. Interference of light means, I give the definition, the phenomenon of, you see the cursor, it is moving, and the phenomenon of redistribution of light energy in a medium, an account of superposition of light waves from two coherent sources, is called as interference. Okay, that means two light waves are superposed with each other. When two light waves are superposed with each other, the light energy will be redistributed. That phenomena is called as interference. Why light energy is redistributed when two light waves are superposed with each other? Then when two light waves superpose with each other, you see, for example, you take this as two slits. Okay, S1 and S2 are the light waves, and the light started from here. For example, the light started from here, and these S1 S2 are the openings, and from that again the light will be starts in the form of spherical wavefronts, and from S2 also light will be started, from S1 also light will be started, because they are the openings. And now you see here S1 S2 are the two slits, and from the S2 and S1 the light will be started and they are superposing with each other like this. And here the light waves are superposed with each other, which are emitting from the two openings S1 and S2. Due to the superposition, based on the type of superposition, either constructive or destructive, it will be there. And at one place where the destructive superposition occurs, there the brightness will be decreases, energy decreases. At other places where the constructive superposition occurs, and then there brightness will be increases. Like that, light energy is redistributed. At some places the more brightness, at some places less brightness will appears, and that phenomena of redistribution of light energy, that is the redistribution of light energy, why it occurs? Because of superposition of the light waves, that is called as interference. Constructive interference is nothing but constructive superposition. It can produce the bright band. Okay, and destructive superposition gives the interference gives the dark band. Now I am going to explain some important topic. There is a condition for the stable interference. The first point is that when we will get the stable and sustained interference, in interference pattern, what you will observe? In interference pattern, if you will see here, and here I am giving the diagram. At here I will redraw the diagram. You see here very carefully, and this is the two slits S1 and S2, and the light started from here. This is the source of the light, and it emits the light, and it passes through the opening. Okay, through the opening it will passes. Now the light will be this S1 is the opening, S1 is the opening, it is a slit, and S2 is the opening. Through the light will emit. The light will start in the form of wave fronts, spherical wave front. Like this, the light will starts. Like this, light will be travel in the forward direction. And here also, the S2 also emits the light like this way in the form of wavefronts. And what happening at here, the light which is emitting from S1 and the light which is emitting from S2, both are superposing with each other. Due to the superposition, if you will keep one screen at here, on the screen, you will observe the bright band, dark band, bright band, dark band, like that. You will observe one bright band. Okay. Next dark band you will observe, and the next again bright band you will observe. Like this, you will observe the bright and dark bands. This is the screen you see here, and here you will observe the again the bright band and dark band. Like this continuously, one bright band you will observe, and other is dark band you will observe. This is the bright, 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 like this. This is a bright, and this is a bright. In the middle of them, there is a dark bands are there. Like this, you will observe the alternative bright and dark bands on the screen. Okay, and now why we are observing the bright and dark bands? Because at the if the superposition is constructive, if the superposition is constructive, you will get the bright band. If the superposition is destructive, you will get the dark band. Like this, on the screen we will observe the bright and dark bands. And what is the condition for the stable equilibrium? Sorry, conditions for the stable interference. Interference is the phenomenon of redistribution of light energy due to the superposition of two light waves, but which should be operate from the two coherent sources. Okay, if coherent sources emits the lights, then if that light superpose, then that phenomenon is called as interference. Interference is nothing but superposition of light waves, but that should be originate from the coherent sources. Superposition means what you know, combining. And now condition for the stable and sustained interference. This is important topic for the 3 marks. And what are the conditions? If you want to get the stable equilibrium, in the stable interference, what happens? In the stable interference, sustained interference, you will get the alternative bright and dark bands. This is the dark band. You see the figure: dark, bright, dark, bright. Blue color we can take it as bright, and black color you take as dark. Like that, dark and bright bands will be forms. And now let us see. This is the bright band. This is the bright, and the next this is the dark. This is the dark. Like this, bright and dark bands will be forms. This is the bright band, this is the bright band, this is the bright band. And now in the middle, the dark bands are there. This is the dark band, this is the dark band, this is the dark band. Like this, bright and dark bands will be forms on the screen, right? And if you want to obtain this one clearly, sustained interference, stable interference, then what are the conditions? Point is that sources must be coherent. Yes, for the interference, the sources must be coherent. Coherent means what? The sources must be emit the light with the same frequency or zero or constant phase difference. And then what is the condition for the next one? Next condition for the stable equilibrium, that the two light waves have the same amplitude. Amplitude of two light waves should be equal for the good contrast in the fringe pattern. Here alternative bright and dark bands are forming, that is called as the fringes. Bright band is also called as the fringe. Bright band, dark band, bright band, dark band. You see the cursor, right? And they are also called as the fringes. If you want to observe the clear fringes, clear bright band, then you should, and clear dark band, then amplitude should be equal. Okay, dark band when it will forms, dark band when it will forms, Then amplitude is A is equal to A1 plus A2. For the bright band, amplitudes are equal means you will get 2A. Bright band you will get, right? If resultant amplitude in case of you see in the destructive A1 minus A2. If they are equal, then we will get zero amplitude. Zero amplitude means complete dark band we will get. That means if you amplitudes are equal, you will get the more bright and more dark. Right? That means dark and bright clearly separated. Then for the good contrast, amplitude should be equal. This is the second condition. First condition, light waves should have the same. Light waves are the coherent light waves, or they should emit from the coherent sources. Sources must be coherent. Sources must be coherent sources. And second condition, amplitude should be equal. I will continue. Take the screenshot and note it. You see here, we are discussing the conditions for the sustained interference. First two conditions we discussed that the two light waves. You see here the picture. This is the source and S1, S2 are the slits, and this is the screen. You see the picture and the cursor is moving. This is the screen. Okay, and these are the slits. Slits means it's a cardboard. You make two pinholes for the cardboard. The two pinholes, through the pinholes light passes. Then they will act as the sources, and these two sources are emitting the light with the same frequency because they are originated from the single source. Okay, and that's why they are the coherent. And now you see here, these are the two slits. Okay, they are emitting the lights, and the two lights are they are emitting the spherical wavefronts, and the two spherical wavefronts which are emitting from the two slits S1 and S2 are superposing with each other. On the screen, you will observe the bright and dark bands. You see here, this is the bright and dark, bright and dark like this. And these bright and dark bands also called as fringes. And you see here, first condition is that we discussed that the sources must be coherent. Second condition is that to obtain the sustained interference, amplitudes of two light waves which are emitting from the sources, they should be equal. Third condition is that the two sources should be narrow. That means here, which is the source? S1 is the source and S2 is the source, and the lights are emitting from the two sources. The two lights are superposing with each other. That superposition, due to the superposition, redistribution of light energy takes place. And on the screen, redistribution of light energy means at some place the constructive superposition is there, at some place destructive superposition is there, and due to that on the screen you will observe the alternative bright and dark bands. At some place brightness is more, at some place brightness is less. That like this the redistribution of light energy is occurred. This is phenomena is called as interference. Interference is nothing but superposition of two light waves. But to obtain the interference, the sources must be coherent, means they should emit the light with the same frequency and same wavelength, and phase difference or the path difference should be constant or zero. This is a condition for the coherence. Second one, to obtain good contrast between the bright and dark bands, uh, there should be amplitude should be equal. The third point is that the sources should be narrow. To obtain the interference, sources should be narrow. Sustained interference. Sources should be narrow means this is the we are making the for a cardboard. This is the cardboard. You see the figure. We are making the pinholes at here. The hole is the pinhole. Through the pinhole, okay, on the back of pin cardboard, we are keeping the source, and this is the cardboard. The cardboard totally opposes the light, but only through the holes the light will be passes. Then through the pinholes. Pinhole is the very small size hole. If the size is very small, then single light ray will be emit, and then uh, superposition and interference pattern is obtained. And the sources must be narrow, and the separation between the sources should be less. You see here, this is the S1 is the one source and S2 is the another source. It's an opening that will act as the source because the light is emitting, light is passing through that. And now this is the D is the separation between the two light waves. Through the cardboard opposes the total light, but only through the holes the light passes, means the holes are acts like uh, sources. They are emitting the light, and the separation between the sources should be less. D should be less, and distance of the screen from the source should be high. Capital D should be high. The sixth point is that sources must be monochromatic. Otherwise, monochromatic means single color. Okay, either single frequency, single wavelength. Otherwise, if you take the white light, then you will get the color fringes. Okay, color fringes you will observe. Thank you for watching my lecture.